Hi, welcome to Eddie's Research. Research in the news, is it true or false? This is originally I posted up the image of a previous article of the thing that I've just done. So this is the climate change, the survey. So if you do want to look at that, I highly recommend you do, because this is the famous bit where everyone says that. In fact, you'll need to read that to understand what I'm talking about in the next bit. But is where they say that 97% of all scientists state that climate change, the 97%, and actually if you drill it all down, you realise where this 97% actually comes from. It's not from all the scientists, and it's not from all the scientists polled, and it wasn't from all the, it's very interesting, but a lot of people don't look at that. So when they say it, yes, scientists did say it, but not really. Anyway, this is a continuation from the original bit of research. So it's where the survey details came from. At the end of that bit of research, I decided to actually look for the values that were given for the survey, and if I can plot a graph from the various places that they're stated from. Now, if you can recall, and I'll just give you a synopsis, if you haven't read it, I'll give you the brief bit. But the survey asked this question: when compared with pre-1800s, 1800s levels, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? So that is what I'm looking at. And you know what? I can't find any site that offers the pre-1800s levels. What does that mean? Well, for one, the survey was asking a false question. Second, the people filling it in. Now remember, if you actually, like I say, if you look at the article, they had only 2 minutes to complete the entire survey, and they couldn't have determined if they were lower than 1800 if there was no sites that showed they were less than 1800. So what did I find? Well, let's take a look and then try and plot the graphs of any data that I do find. I actually plotted all the graphs at the end, so it's easier to see at a glance. Okay, so the first website we went to is Climategov. Okay. And if you see here, there's the graph, and if you look, it actually only goes back to 1880, and this is a government website, 1880. So it doesn't go back to 1800 as it stated before. Now that, sorry, I moved it a bit better there. Put it back. The zero line here represents the long-term average temperature of the whole planet. Blue and red bars show the difference above or below average for each year. Okay, now the source data from that comes from here. So the source data is down here, so it stands out like a sore thumb. And there you go. So there's all the numbers there. Now the actual image is of both the land and the sea, or the ocean, combined. It offers land, sea, and combined in here. If you look here, land, land and ocean. Okay. You can drill it down to years that you want. You can drill it down to the month and latitude and longitude if you know any of that rubbish there, and the region. So we can split them out and create some graphs. But one thing I noticed on this site, and I'm curious if it's the same elsewhere, is where did they take the readings from? In the case of the main graph, it's global. This is global. But there is a chance to split per region. So let's just randomly select North America. Plot that one. There you go, see. Now, this will take some time, but I actually did do it. I know it creates a graph for you, but I just want to make sure that they're correct, as the pictures can tell 1,000 words, and if the picture isn't correct, well, There you go. Your eyes just look at it and go, yay! And it might be wrong. I mean, I don't know. But I do know. Plus, I want to compare graphs. It's far easier if I plotted them all the same way and not how one website does it different to the next. So, the data for this site is stated. It's stated from the NCDC NOAA Gov. Now, this is a different website than originally. Yeah, so originally it was a government website, and now we've jumped to a NOAA. So here's the website, same place, same stuff, and it says global temperature anomaly data comes from the Global Historical Climatology Network Monthly Dataset and International Comprehensive Ocean Atmosphere Dataset, which have data from 1880 to present. These two datasets are blended into a single product to produce the combined global land and ocean temperature anomalies. The available time series of global scale temperature anomalies are calculated with respect to the 20th century average, while a mapping tool displays a global scale temperature anomalies with respect to the 1981 to 2010 base period. So we end up jumping around into some websites at the moment to get all the details, so bear with me. So the first one here is this dataset here, and there's the dataset. Yeah. Now I actually clicked on version 4 because it's the latest version. There's no point me clicking on the first couple because then I'd spend ages messing around. So, this is the website. So it states at the top, the Global Historical Climatology Network Monthly Dataset is a set of monthly climate summaries from thousands of weather stations around the world. The monthly data have periods of record that vary by station, with the earliest observations dating to the 18th century. Some station records are purely historic and are no longer updated, whereas many others are still in operation and provide short time delay updates that are useful for climate monitoring. So it states that it goes back to the 18th century. That's correct, it does, but only to 1880, not to 1800. Okay, so let's go back here. The second link is to this website. It just blends, doesn't it? You know, you can just see it's so easy to understand. So it says here, the International Comprehensive Ocean Atmosphere Dataset offers surface marine data spanning the past 3 centuries and simple gridded monthly summary products for 2 degree latitude times 2 degree longitude boxes back to 1800 and 1 degree times 1 degree boxes since 1960. These data products are freely distributed worldwide, as it contains observations from many different observing systems encompassing the evolution of measurement technology over hundreds of years. ICOEDS is probably the most complete and heterogeneous collection of surface marine data in existence. So it states that it goes back to the 1800. Where is it? There. So why isn't that listed on the Ocean's options in their own database? Which you saw back there, it only goes back to 1880, so why not put that in there? You know what I mean? So clicking on the data and products takes you here. Okay. And from there I actually found the site where the data is. It's down here, monthly summary statistics, and it is here. Believe it or not, it's so easy. I mean, you just jump around all over the place to find this stuff. It's not like it all just sets it there and says, here's all the values, get it from here. Otherwise, everyone just gives up. and then you end up here. However, you do need access to view the file. Okay, so you can't view the file from 1800. And the contributors are here. And on my website I've written them down, but you can hover over them. You can see this, who they are. Met Office, we'll talk about them in a minute. UCAR there, these are here. You know, you can see which ones are doing them all. Yeah, and it tells you there as well. It tells you a bit more about it there. Okay. Well, so if they have the data, as I said, why don't they plot it? Never mind, we can only go on what they have available. I mean, if they don't show us it, we can't go by what they tell us. Right, we've got another site to look at next. So I've got some of this data from the previous things, so that's that. So here's the second place where we're actually looking for the actual, the main graphs. It's the DataHubio. So here's the graph, but again, 1880 to 2016. There. Okay, only 1880. So this one's actually the monthly temperatures. Monthly temperatures. They have a README on where the data comes from. It's actually here under Read More. Okay. So it tells you there it's from 1880 to the present, and the areas they come from is the GISTEMP, Global Land Ocean Temperature Index, and the global component of climate at a glance. Okay. Well, the first one will go directly to the site. In a second, which is this one here. But the second one we've already looked at. See? So that's taking it from the data that we've already seen. So we don't need to look at that one. So we've already got the data from that. So the actual DataHub.io don't have any data of their own, as opposed to the other sites that have data. I mean, the government website doesn't have their own data, they nick it from someone else. So anyway, on to the third website. So here we are in glorious NASA. So this is obviously going to be completely true because it's all the way up there and we've got satellites dotted all over the place. So where's my graph? Where is it? We have a graph somewhere. There it is there. It's 1880s again. Anyone spot a pattern? Back to the 1880s. So there is a graph. So it's not on the main web page as such because you were looking and you probably never even saw this image, but this is their image. 1880 again. As I say, they don't seem to go that far back. So this isn't very easy to look at, is it? I mean, you look at that and you think, what the hell does this mean? But it does seem to show the increases and decreases at the exact months. So, it's cold and up and down. So that's interesting. So here we are back on the main page. You see it's not there. Well, it is there, but it's kind of hidden away. So at the top here it says the GISS Surface Temperature Analysis version 4, the GISTEMP 4. It's an estimate of global surface temperature change. The graphs and tables are updated around the middle of every month using current data files from the NOAA GHCN version 4 meteorological stations and Erst V5 ocean areas, combined as described in our publication Hansen et al. And Lenson et al. These updated files incorporate reports for the previous month and also late reports and corrections from early months. But to find out what the actual values they use, which probably come from a multitude of places, at the very bottom of the main page, it states here so this is where they all are. So you can find them all here. So I actually looked at the global, the northern and southern hemisphere details. Strange enough, from the first site that we looked at, remember, it goes into a lot more depths. Africa, Mexico, etc. But at NASA it's just two areas and global. So you have global and you have north and south, and that's it. Whereas that other one has, like, I don't know, India and things like that, and Mexico. So as I say, there they are, and you can click on them here. These are the ones that I looked at. Okay. So this is the snapshot of the global values. Obviously they're very large, but there's a calculation that needs to be done to get to the correct values. You divide 100 to get the changes in degrees Celsius and multiply that result by 1.8 equals 9/5 to get changes in degrees Fahrenheit. Well, I'll be using degrees C as the other sites were listed like that. Plus it offers a mean of January to December, so again I will use that value and not the individual months, as the other site was overall as well. But if you actually download the CSV instead of the TXT file, it converts it to the correct decimal points, so it's a win-win situation. So the fourth site we're using is crew data. At the very top, sorry about this, but basically they've changed the website, so this usually happens. I basically started recording this just recently, or doing the editing stuff, so the main bit here is here. It was at the top of this page, but they've updated the website again, which is awesome. So these datasets have been developed by the Climate Research Unit, University of East Anglia, that's in the UK, and NCAS jointly with the Hadley Centre, the UK Met Office, apart from the sea surface temperature dataset, which was developed solely by the Hadley Centre. The original bit also then said these datasets will be updated at roughly monthly intervals into the future. Hemispheric and global averages are monthly, and annual values are available as separate files. So they've changed it a little bit. You probably just embedded in here a little bit easier. So my data set might be a little bit dated, if that makes any sense. And the actual data is here. Well, again, they've changed it. So it was just here, and that was all I had, but they've since kind of changed it a little bit, so that these the dates have changed a little bit, not by much. I did it in August, so it's not updated that much. But I'm not that fussed about the previous ones as such. So these are DAT files when you download them. See the bottom there, the DAT files, which is a lot of copying and pasting. And again, it's just the two areas and global when you download them: northern, southern, and global. But 4 data sets for each. Move on up when you open it up. Some of the dates go back to 1850, so I'll add them in, even though the previous sites were all 1880. Okay, so now we go to the Met Office in the UK. This is actually quite a good website because you have some details about anomalies. It's a word I can never say well. And Absolute temperatures are not used directly to calculate the global average temperature. They are first converted into anomalies, which are the difference in temperature from the normal level. The normal level is calculated for each observation location by taking the long-term average of that area over a base period. For Hadcut 4, this is 1961 to 1990. For example, if the 1961 to 1990 average September temperature for Edinburgh in Scotland is 12 degrees C and the recorded average temperature of that month in 2009 is 13, the difference of 1 degree C is an anomaly, and this will be used in the calculation of the global average. One of the main reasons for using anomalies is that they remain fairly constant over large areas. So for example, an anomaly in Edinburgh is likely to be the same as the anomaly further north in Fort William, and at the top of Ben Nevis, the UK's highest mountain. This is even though there may be large differences in absolute temperature at each of these locations. So that's quite useful to and this anomaly method also helps to avoid biases. For example, if actual temperatures were used and information from an Arctic observation station were missing for that month, it would mean the global temperature record will seem warmer. Using anomalies means missing data such as this will not bias the temperature record. So it's very, very useful. But when you look at the page, you will scroll up and down reading all of this, you can't spot any data. There's a graph. 1850 again. A bit lower, obviously. You're looking through and you think, well, this is very nice. There's the websites we've already been to. Look, there's then in this graph one, there's the NOAA. We've been there. So where's the data? Well, it's there. It's all the way down here, under data, tucked away at the bottom. So you can't see it. Most people won't even bother looking down there. They just go here and go, there's nothing there. So when you click on it, it takes you here. So this has, again, various links to various sites. Again, quite lengthy. But it's interesting if you want to know about lake levels. If you want to know about, let's scroll down, there's some various things here. Data points, fish and various other things. There's all sorts of bits and bats here. It's quite an interesting bit about it all if you want to have a look at it all. So as I say, you could click on this one, for example. It brings you here, and you think, oh, this is interesting. What the heck is all this rubbish? And then there's data sets. This is the things you want to always look at, is data sets. And it comes back here, and you think, well, what's all this again? And there's Copernicus Climate Data Store. Click on that, and then data sets up there, and then you can have a look at this to your hearts. This is what I'm talking about, water level. So there's your water level time change for the European coasts. Your sea surface temperature, your fire danger indicator. I mean, you could live if you just want to spend time researching, not even researching, if you just want to read. So you're just curious, and people keep telling you about fish abundance and stuff like this, and they're saying, well, it's definitely not abundant. And you think, well, I'm going to look at this. I don't know what it does when you open it up. There you go. So you have this long list here, and you could read about this to your heart's content, and you can probably download the thing somewhere. I don't know. There it is. Download data. You can download it all. You can knot it down to gilt head, sea bream, and anchovies. It literally is. If you really wanted to, you could just live in there. If you're that bored, look at it. Just goes on and on. So it's a massive website, and that's just this Copernicus one. Anyway, I'm not going to dwell on that, as there's so much I would need a lifetime to see through all this lot. So again, there's another website, is this Umestat. So again, you end up another website. There's Copernicus again, and you can click on here for where is it now? How to access our data. They just changed the website again, it's like everything else. And then you click on New User Getting Started, but there's a product navigator there, so you click on that, and that comes up here. And then I just typed in, for example, global service, and up comes 213 hits. But unfortunately, you need to actually pay for the majority of these, or be a member. And I'm not going to become a member just to scour through all this. I could, you know, I mean, 10-day leaf area index, and you know, this is the. I'm just jumping off a tangent, but sometimes what happens in many of the world out there, in the world of YouTube or whatever, is people say, "Oh, nobody's ever told us this. They keep all this hidden." No, they don't keep everything hidden. It's there. It's just that people don't look. All this stuff. It's not like we were there looking at the website for, you know, Met Office. It wasn't there, and all the others weren't there at their website. They're sort of dotted about. You gotta kind of look, and look. You can see them all here, and then you could look at all this stuff because it's all there, but people just don't read it because they just. Most people, unfortunately, attention span on the internet is quite limited because you kind of just want things now. You don't want to spend ages just going through stuff. Not all, you know, everybody's different. So we're back here again, and there's the Met Office Weather Data Hub. So I clicked on that one, and again ended up here. Okay. I thought looking at the first one review, so I clicked on the Learn More. And again, it seems that you have to pay. Now this is a poor thing, as the Met Office is one of the main sites out there for temperatures. To have it hidden unless you pay for it is not good. So again, how are you supposed to determine if the results are correct if you have to pay for it? So I looked at some other places, and yes, the UN has stuff, but as usual it's in a report, as they don't collate the data themselves. So here we are in the UN, and like I say, they don't collate this. They just collect the data and they just bring it out. So I'll be explaining a separate video about this kind of thing, as again I don't have the time or the energy to read all this lot. So basically, they have loads of, and this is again harks back to that. They don't post anything. Well, they do, but there's so much. I mean, you could live in here because they post these things up more or less daily. I mean, let's pick something that's. I mean, who would have thought that the in 2020 they were still doing this stuff? So if we just glance at the state of the global climate in 2020, so you actually click on the report, and there it is. There's a little scrolly bar, and you've got the blurb, and you can click on these for extra things, and you can usually download a PDF for it. Is there a PDF for this one? No, not this one, but you can probably download it. I mean, again, you could be here forever, you know, really forever. But I did find one that was quite in depth, so let me just show you this one. So this was actually from their website, and it kind of jumped it back to something else. And this is a global temperature data sets overview and comparison table. And again, it's another website, not from the UN, it's just another website for values. So the bottom it gives images. There's your images that you've got there. And on the left we'll open up the related pages. So we click on that first one there. You end up here. There's your image. There's your scrolling bar. At the top is your get data. There. And yes, you can click on all of these and plod away with even more numbers. But as there are 6 comparison charts, and each may have 5 or 6 data sets. So if we click on this one here, there. You know, yeah, you could be there for literally for forever. Oh, the laptop's about to reboot. That's not what I want. And the final site I looked at was this one. And again, this is just one report, and yes, you can download it for free. It's here, download it for free. But on that site there are hundreds to look at. Hundreds of pages, hundreds of data sets. I mean, you're looking at the last 2,000 years for a start. Of any I've glanced at, this one looks the most interesting for me. I mean, you know, I'm kind of sad that way. So I've since plotted all the graphs from all the above. I've plotted them as individual graphs from each respective data and combined. So I'm going to show you them all here. So we're going down in order of where I found them, and I plotted them all as more or less the same size. I've got all the Excel sheets, so I'm going to upload those if you want to go through them to your heart's content. But here they all are. So we'll go through them in order in a second. Here we go. So this is global from how to cut. So as you can remember, the famous 1, when it hits above 1, that's when it's bad, if you remember, in the news. Northern Hemisphere, Southern Hemisphere. Global. Different now, it's cut EM4 at the top. Northern Hemisphere, Southern Hemisphere. Then the cut M4V, so there's global. Northern, Southern. Bit of a wiggle one there. Had SST3, there's your global. Your Northern and your Southern. In NASA, there's your global. Your Northern and your Southern. So with this is where we get a bit more in depth. So we have the land and ocean global, the Northern, the Southern, the Atlantic, MDR, I don't know what the MDR stands for, Caribbean Islands, East North Pacific, Gulf of Mexico, Hawaiian region, global on land, Northern, Southern, Africa, Asia, Europe, North America, Oceania, South America, and then ocean global, Northern, Southern. There we go. So as you can tell, there's a lot, and you can't really see any correlation. So I replotted them all, but on one graph per main area. The main 3, not the random ones that the NCDC had. So there's the Southern Hemisphere. Right, here we go. There's the global. So you can see there's a bit of difference there. I'll leave that on the screen so you can see it. There's your northern, and there's your south. Okay, so that's easier to see instead of many graphs. You can see various things here. Yes, it's rising. Strangely enough, just around the Industrial Revolution, yeah, that's when it started to rise. And it seems to peak during World War II. Oops. But they're vastly different depending on where it's taken and by which recording site, so to speak. The Southern Hemisphere is not even at 1 for most of them. Only 1 here, the NCDC land. Bear in mind that the others that are not NCDC don't state that they're land or water. The Northern Hemisphere Northern Hemisphere. Not all are at 1. There's 1 there, so you've got a few there that are low. We have some just hovering above 0.5. There. And global, yes, it's at 1. But again, not all 4. Some are a lot lower. Again, near 0.5. I could drill this down even further, but I haven't got the time or the energy, and what I have already done is a lot more than many scientists and news sites and other researchers do. So my conclusions based on the actual numbers are that it's not over 1 for everywhere. It all depends on which location you take the readings from and which site you use to collect the data. I know that many will argue this point, but I'm looking at all the values that are available in the public domain. If people cite something hidden, then I can't agree on that, as we cannot see the numbers. It's like me saying I have over £1,000 in a bank account and it's investing big time and making hundreds of pounds daily. I can't say who I'm investing with, the shares, etc., or even show you the account, but it's real, as I'm telling you. Anyway, as always, please let me know what you think of this research, and thank you for watching.